Hello, so today we are going to do this problem called construct binary tree from preorder and inorder traversal. So we have two arrays, preorder and inorder. Basically, preorder is just the tree processed in preorder traversal. So preorder is root and then left and then right. And so here, the first root, that's 3. Right, and then that's what we have here, and then left, so the root of the left side 9, and then since there is nothing after that, we go back up, we go to the right, the root on the right side is 20, and so we go after roots, we go left, the root of the left is 15, and then after that we don't have any children, and then we go right, so root left right is 7. And also we get inorder array. Inorder is left, then root, then right. So in the usual order, left first, root, and then right. And so here, left first, so the leftmost is 9, and then the root of that, 3. And then we go to the right side, but we recurse, right, so that we go to the leftmost, so we get 15 leftmost, and then we get the root, and then we go to the right, which is 7. So we get the two arrays inorder and preorder traversal, and our goal is to reconstruct the tree and return it. So this is a representation of the tree, but we'll return it in a format of a tree node. And here just an example with just one node, which is -1, so we just return -1. Okay. So that's the problem here. One thing to note is that they say here that we are guaranteed that preorder and inorder have unique values, so there is no duplicated values in the tree. So that makes it easier to solve. So let's see how we can solve it. Okay, so let's see how we can solve this. So the main thing to note here is that preorder gives us the root first. So here we get the root 3 first, and then we go left, so it's preorder is root, left, then right, and inorder is left first, root, and then right. Okay, so here we have the root, the first root, and then we go left, right, this here, and so we do left, so left, the root of the left 9, and then we go right, the root of the right 20, and then we go left, the root of the left 15, and then we go right, the root of the right is 7. So you can notice here, as we go with preorder, we will get each time we get an element from the front, we get the root. And so that's the main thing to note here, is that we can use preorder to get the root. Each time, right? And then once we get the root, so let's say we get the root is 3, we can check in our inorder, because in order we have the root separating left and right. So we have root separating left and right. Okay, so we get the root from the preorder, so it's 3. How do we know the left side from the right side? Well, we can just get the index, and then the index of the root, whatever is to the left of that index, it's the left subtree. Whatever is to the right, that's the right subtree. So what this means basically is that this is the left subtree, and this is the right subtree content. Okay, and so that's pretty much it. That's pretty much the idea, and we can just recurse and keep doing this until we are at the end, and the end means we don't have any elements to process anymore. So that's the main idea that we are going to go from. Now, one thing that will help us with the preorder, so it's 3, 9, 20, 15, 7. If we make it a queue, a DQ, then we can pop from the front. So we pop the first root, and then in the next recursive call, we pop the next one, and then we pop the next one, and that way basically we can obtain the root in the right order. Okay, and then once we get the root. So let's say we do q pop left to get the root. Of course, this is the root value. Then we can just take the inorder, so and get the index. So in that, when we pop 3, we would want to get the index of 3. So here it's 1. So we get the index of 3. So root value. That will give us the root index, right? And then we can just do our recursive call. And our recursive call, let's call it recurse. We need now to determine what are the parameters that we need to pass for the left and the right. And we need to assign those to the left side and assign it to the right side, assign another set of values. Okay? So here we need to assign 2 parameters. Now, what can be our 2 parameters? So actually, what we need, we know that for the preorder, we will just use a dequeue and keep popping. So we don't need to worry about that. But for the inorder, we want to get the indices of what's the start of the left side, right? What's the start and what's the end, right? So that we can now, okay, this is the right subtree. We pop the root of it, which is 20. We want to know where is 20 in this sublist, right? And so what we need for basically our recursion is to know the start and the end. That will help us also know when we are done, because when we are done and the list is empty, then we will have start bigger than end. Okay, so that will also help us with the base case. Okay, so now let's see the parameters. So we know that the parameters are start and end. What's the start for the left side? So first, what's the start for the first call, right? So for our first recursion call, let's call this recurse in order, right? Or recurse maybe for now. So for our first call, well, it's the entire array, so it's 0 to the end here, which is the length of inorder minus 1, right? So our first call, we need to call it with 0 and then the length of the inorder minus 1, okay? This is the start, and this is the end. Now, to process our left side, what is the starting point and what is the end point? Well, the starting point is the same as whatever it was the starting point before. This is important because when we are looking at this one and we want to recurse on the left, we want the starting point to here. So it's the same starting point that we got in the parent call, right? So this is start. It doesn't change, right? Because left is just from the start to this index here, which is just the root index minus 1, right? Because remember, for inorder, it's left, then root, then right, which means that the left side starts before the root. So we can just say, let me just give space here. So we can just say it's the root index minus 1. That's where the left side ends. Now, what about the right side? So the right side begins just after the root. And so it's root index plus 1. And when does it end? It ends at the previous end. Okay, it's the same end as the caller, so end. And then we can return the node or the root, whichever you want to call it. And that's pretty much it. So, however, one optimization we can do is here, instead of having to do the index every time, which would be linear, we can just have a hash map that we populate initially using the inorder array that will allow us to find the index easily with O of 1 operation. Yeah, and that's pretty much it. So let's write this down and make sure it passes test cases. Okay, so let's write our calls here. So we know that we need to recurse, and the start point is 0. The end is length of inorder minus 1. Okay, and we want to return this. We can name it to recurse inorder because actually we are recursing on the inorder array. Okay, and so let's define this function here. So that function is on start and end. And start and here are for the in-order array or list. Okay. Now we need our pre-order. We need to convert it to a DQ so that we can easily pop left, pop from the front to get the root. You can maintain, alternatively, you can maintain just the index of where you are in the pre-order list and just keep incrementing it. Yeah, but this one is just easier, so we can do pre-order Q or DQ. And that would be just, we can use collections in Python, DQ, and then just pass as a parameter our list. And now we need also, as I said, to make it easier to get the index, we want to map from the values to the indices for the in-order list, because every time we'll want to check what's the index of the root in the in-order list. And so let's call this indices, okay, or maybe in-order indices. So we get the value to the index, so it maps the value to the index, and we can just, in Python, it's easier to do this way. You can do it with a for loop as well if you want. And now this would be for in order. Okay. Okay, so now we have everything we need. We need our base case, which is once the list is empty or start is bigger than end, what do we return? So empty, we would want to return none, so that the left and the right child are marked as none for the tree. And now we need to do the node, which we said the node value or the root value is going to be just popping from the pre-order list. Okay, if you had maintained an index, you could just pass that. And then let's call this root. It's going to be tree node, and we are going to pass root value. And now we need to get the index. So root index is going to be from the in-order indices. So that makes it easier for us. And we are going to pass the root value. And now we can recurse for the root.left and root.right. And then at the end we can return our root node. Now here we want to recurse, we want to pass the start, as we said. So start is going to be the same for the left side, and the end of the left portion is going to be just before the root, because in order is left, root, right. So let's just write that down. Left, root, right. This is for the in-order traversal. So what this means here is that the end is going to be just the root index minus 1. That's where the left side ends. And then we can recurse as well for the right side. And the first element of the right side is just after the root. So it's root index plus 1. And the end is the same, right? Is the same end as before. And that's pretty much it here. So let's run this, make sure it passes. Okay, so here there is a slight thing we need to do, which is we need indentation to indentate properly. Yeah, so here it's not the pre-order, it's pre-order DQ that we want to pop left from. Okay, that seems good. Let's submit. Okay, yeah, so that passes test cases. Yeah, please like and subscribe, and see you on the next one. Bye.